I'm the Director of Air Environment, a specialist air quality and odour consulting company in Australia. We do projects all around Australia and overseas as well, around the world. I'm chairing this session and I'm also the first presenter in the session. We've had some good talks this morning and we've got some more talks coming up that are very nice. The next couple of talks in the session. My talk today is on, it's a little bit more broad than what was advertised in the program. So it was advertised as ambient odour assessment using a couple of the field olfactometry and ambient odour assessment methods using the European and VDI assessments. They're not methods that we use in detail in Australia. I've got a couple of case studies I'm going to present on that, on ambient odour assessments, that we use some modified techniques. We use some of the methods in those standards. We don't use the full standards. But I'm also going to talk about dispersion modeling and odour sampling and some issues with odour samples, odour sampling techniques and devices, and also different ways to use dispersion models to get an outcome in odour impact assessment. So, as I said, I'm going to talk about some methods. I'm going to talk about issues and important considerations. And I'm going to talk mainly about reverse amenity odour impact assessments. These are sort of situations where we're working for, our client is a developer or someone who wants to put in usually residences or commercial business or something close by an odour generating activity. I'm going to talk about two case studies where our client was a residential development company and they wanted to develop close to a composting facility, green waste composting, and another client wanted to develop close to poultry sheds, so a very, very large farm complex, about 40 poultry sheds over quite a large area. There was a group of sheds that were close by our site, and the farms were naturally ventilated, so they had open sides. There was a little bit of sort of free range, allowing the birds to get out. And that was a new activity that they brought on more recently. So it wasn't the tunnel ventilated sheds where large volumes of air are pushed out using a fan. So we're going to talk a little bit about how we did the two studies. We talked about odour sampling, we used olfactometry testing, dispersion modelling, we used ambient odour surveys to ground truth and validate modelling, and as a basis for the main part of the study. We talk about odour concentration, intensity, and hedonic-tone relationships. And we talk about the importance of site meteorology, not just predicting using a prognostic model. Analysing complaint data as a validation tool for models as well, and to fill in some of the ambient odour surveys. And we're going to talk about the generic separation distances that were applied to the two activities. And essentially our clients were looking to challenge those buffers and build within those buffer regions. And maybe those separation distances were generically applied as a radial distance, and obviously you had no consideration for site-specific sources or meteorology or terrain or land use. So some of the issues with reverse amenity assessments around large fugitive emission sources such as composting plants and poultry farms, they're usually spatially and time varying in their emission profiles. So this makes it difficult to understand the emissions. We had a speaker this morning talking about such things as wastewater treatment plants. It's hard to understand the difference in the emission rates, time varying. Composting is related to seasonal diurnal effects, age of the compost, the processes that are used, whether the piles are static and in the same place for a while, or they're turned often or not often, whether they go anaerobic, and that sort of thing, create different odour profiles. And poultry emission cycles, as you'd be aware, is one day old birds on fresh litter don't really smell, and by day 35 in the first thin out, the smell's getting right up there as the bird mass increases. The issue with the reverse amenity situation is that often the buffer that protects people from odour impact from these sources is not owned by the company that creates the odour. The land has economic value to someone, somebody owns it, and so eventually with a lot of increase in population growth, and there's a lot of encroachment of residential areas into these buffers. So there's a lot of pressure, there's a lot of work that we do dealing in this interface between residences and industry and working in these buffers. Often the buffers have been determined somewhere, sometime, or just someone has invented a number and said you can't build within that distance, and there's no regard for any site-specific activity. So some of the issues we have is when we're thinking about how to do these assessments is, do we have access to the actual facility creating the odour? So because we're working for the developer, generally we don't have access, and the company that creates the odour, the actual industrial activity, doesn't want you building in their buffer, and so they won't let you onto the plant, they won't give you any information, so you have very little data. So that was the case in our second case study with the Poultry Farm. They obviously didn't want to know us, and we had no information about how their bird cycles work. We were able to glean a little bit of information after a while that it was publicly available with their environmental protection licence, so we understood generally the farm groups and how many birds were placed, but the sheds were all different sizes, so we didn't know the actual number of birds per shed, and we didn't know the cycles of when they were placed and how long we knew that they grew. They did a 9-week cycle, so it was about 7 weeks and then a 2-week clean out. But that's about all. We didn't know what days and what time of the year those cycles started. We also, usually there was 4 or 5 sheds per farm group, and there was about 8 farm groups in this area, and they weren't all placed on the same day, so it's all very staggered. So the emissions don't sort of all go up and then come down and all go up, they all sort of stagger. We didn't have that information, so that's important to know when you're doing the ambient odour survey, when you're doing this impact assessment. So also, how are we going to actually, if we do get access to the site, with a composting site, we're able to get access to the site. So how do we actually collect the samples? We have a set amount of, on any particular day, we go for 2 or 3 days of sampling. You've got compost windrows of a certain age, but those change all the time. So you need to somehow create an emissions model that accounts for varying emissions over time throughout the year when you're modelling every hour of the year. When you're doing ambient odour surveys, of course, you can go as many times as you can afford to, not with a client's budget. So how many times is enough? You go for like 2 or 3 hours per survey, but you don't go every hour of the year. So residences are there every hour of the year, so you need to try and work out what conditions you're going to go, what are the worst case porous dispersion conditions, if you can try and match that, and we had to look at that. On-site meteorology is another very key element to understand not only the conditions of doing ambient odour surveys, but in validating your dispersion model or actually using the meteorology in a dispersion model. So some of the odour assessment, as Australia as an example, some of the odour assessment policy and guidelines are mentioned here. Most of the policies are odour modelling based. They have criteria based on 2 odour units, 99.5th percentile, 1 hour or 3 minute average. Some of the policies, they're all state-based policies, and every policy is different with a different modelling criteria. Some of them mention ambient odour surveys and that you can do them. Some of them actually mention an intensity level, like weak or distinct, but there's no more guidance around it. They mention there's the VDI 3940 standard, and that's about it. There's no guidance as to what constitutes nuisance or compliance or anything when it comes to ambient odour surveys. Odour complaint data management and reporting on odour complaint data, analysing it, that's part of the policies. Sometimes they get serial complainants to create odour diaries and log the times they get odour. And community surveys are sometimes done. And community surveys are done much more in New Zealand than in Australia, but they have been done quite a bit. But I find them, depending on the questions you ask, the value in them is really serious. And then, of course, the other way to manage is separation distances. This is just a table of some of the odour policy, all the odour policies in Australia. You can see they range from 2.5 odour units in Queensland and 0.5 for tall stacks, 2 to 7 in New South Wales, 2 to 10 South Australia, 1 odour unit in Victoria, and different percentile statistics like 99.9 percentile, 99.5 and 99 percentile. I know in Europe they use 98, and we have things like 1 second averaging periods, so nose response time, 3-minute averages and 1 hour averages, so they're all different. So one of the studies we did was that I'm going to show is the composting one was in the ACT, Australian Capital Territory, and they don't have an odour policy. But the auditor on the site we work with, he decided he wanted to use a South Australian policy. The other one, the Poultry Farm, was in Queensland, so we were working on fugitive emissions, 2.58 units. So this is the green waste composting site that we were doing work at. This is in the middle here. This is in the middle here. And the yellow line is the 1 kilometre buffer around it. There's a number of other sources. The wastewater treatment plant that's just down here off the screen. It's got a 2.5 kilometre buffer around it, which is, I couldn't believe it, it's quite astonishingly large. The wastewater treatment plant, and it was newly upgraded. I don't know how they didn't reduce the odour any more than that. There was a landfill which was pretty much finished. They were just taking some asbestos, and so they had a 500 metre buffer, but there was really no odour from the landfill. I think most of it was dry waste, and it was pretty old and pressable. And there's a poultry egg laying farm as well with a 750 metre buffer there. So our client was looking to extend this residential development here in the east right across this area. This is sort of flat along here, it's a little rolling rural, and it drops steeply. This is the Murrumbidgee River Valley, so this drops steeply away here. And they were looking to build 11,000 houses over 40 years in this area. This white line here is the New South Wales ACT border, and the development was going to push into New South Wales. So it's a really, really big development, and it was critical for the ACT because currently they're running out of land for residential development. Okay. So that's just going through some of that. So we were actually able to get access to the composting facility in this study and actually take odour samples. So the client actually wanted us to do an odour sampling method. Odour sampling is the Australian standard for area source sampling method, so that means the flux chamber. It doesn't mention wind tunnels in it, only the flux chamber, and using olfactometry and then cow puff dispersion modeling. As I mentioned before, the odour guideline in South Australia was used, and 2.5 odour units, 3-minute average 99.9, so it's pretty strict. So that's the top, basically usually allowing for model error. The 99.9 is usually used to just get rid of the top 9 events, or top 8 events, and 3-minute averages, it's a pretty small averaging period for 2 odour units. So it's a pretty strict guideline. We recommended ambient odour surveys needed to be done in order to validate the model and to understand dispersion in the area. But we were only at the site for about 4 days, because we had 2 days of odour sampling and 2 days where we did some ambient odour surveys, and we did 2 days of ambient odour surveys, and then during the odour sampling days we also did a little bit of ambient odour surveys before and after the day's sampling. Okay, so some of the things we need to understand about composting and considerations when we're doing an assessment is the total number of samples to collect and how many is representative. We're able to, due to the capacity of the laboratory, we took about 10 samples per day, and then got them to do some odour intensity tests on them as well. So that was pretty much the capacity we filled the lab up for the day. And we obviously had cost considerations of how long we could be there and how many samples we could do. So it was 20 samples plus the intensity tests for the first sampling. We ended up doing the study during winter. The client just said, go, do it now. And it was during winter, and Canberra's quite cool, about 0 degrees in the morning, gets up to about 6 to 10, maybe 15 in the afternoon. A bit different to the summer when it can get up to 35, 40 degrees. And it was just a question of go now, I need a study done. So it was winter conditions. Once we did the assessment and the modelling, to skip ahead, the auditor actually asked us to go back and do summer sampling as well. So we had to go back and do the whole thing again in the summer, because the compost potential odour emissions can change quite dramatically in different seasons. One of the other issues we need to consider from our experience was the crest. Emissions from the crest of a windrows are different to the sides and lower down near the floor of the stockpile. We've seen that flux chambers which is the Australian standard, underestimate odour emissions from sources where it has a net outflow. And you tend to get a lot of heat in composting windrows and convection up through the cell, and sometimes the air can be drawn in at the bottom and go out through the top like a chimney, and the flux chamber doesn't handle that net outflow very well and tends to underestimate emissions. So we took our wind tunnel with us and decided to do a couple of comparative tests, and I'll show you the results in a sec. So we need to consider stockpile ages. There's a variety of stockpiles of different ages across the site, and they all have different emission rates depending on the biological activity going on in them and that. Turning of stockpiles is an important odour source. Usually when you turn the pile, if the anaerobic condition is not well aerated, you get a rush of odour as you break into the pile and lift it up. This plant didn't have great management of stockpile composting. There was no measurement of aeration or temperature. There was no requirement to monitor. There's no standard composting in the ACT. They only really turned the stockpiles when they had to relocate them because they had more material coming on the site. So they basically moved the stockpiles down the pad and put new material, and they just seemed to get sort of older as it went down and then out towards the front gate where they sold it on. So we had to consider the sampling methods, we had to consider the seasonal and diurnal effects and concentration relationships, and also one of the other important things was meteorology on the site, actually having site-specific meteorology. Unfortunately, they put a MET station in. Our client, building 11,000 houses, put a MET station in about 2 weeks before we turned up the sampling, so we didn't have a year of MET data to do this modelling with. This is an image of the sampling we did with the flux chamber and the wind tunnel on the crest of the windrow. And so then these are the emissions from the winter sampling. You can see in this, this is the profile we got from the flux chamber up at the top here. The flux chamber on the crest, and then the blue line down here is on the sides. You can see quite a difference. And these are the ages of the stockpiles. So you can see that once the biological activity slowly gets going, and this is winter, so it's a little bit slow, it ramps up and then it trails off after a bit of age, and you get to about 16 weeks. And then I think they move the piles to another area and they screen them for sort of coarse material and fine material, and then these are a little bit different, and then the odour sort of trails off and there's not a lot of activity. They're fairly compost and mature at around this sort of 16 weeks. We took the samples, these sort of different ranges of samples, and then we sort of modelled the sort of maximum. We then looked at the wind tunnel results, and we scaled up this profile here is this red line here, this profile, and this is with obviously a different y-axis scale, so this is the flux chamber, but the wind tunnel produced slightly different results. So we scaled for the max, and you can see it kind of fits reasonably well. So we ended up thinking, which one is which profile? This is like 10 times more odour, and we know that flux chambers underestimate on the crest. You can see if we were taking on the sample on the side, they'd be massively underestimated. So, and that's with the flux. We only use the flux chamber on the side of the emissions, the side of the windrow. So we looked at these two profiles and thought, which one's correct? Let's model both of them. When we went back in the summer and did the sampling, we got this profile. Because of what we'd seen and modelled in the winter, we decided to do more wind tunnel sampling the second time around and less flux chamber. So we did some more like comparisons with the flux chamber and mainly wind tunnel. And you can see there was a lot more stockpiles of much older age on the site in the summer, and we were able to get more samples from the older stockpiles, and you can see they went up here. And this again is the flux chamber down the bottom. So this is the mean and the maximum results. Okay, so then we did the modelling, and we started off by modelling just the undisturbed stockpiles, so not accounting for turning. We did some sampling of the turning as well, and you can see the picture on the left. The 280 unit contour just touches the boundary of the plant. It's a tiny amount. We've got the 1 kilometre buffer here, this is suggesting if we use the Australian standard flux chamber method and the standard cow puff modelling, that we could reduce the buffer right into this line. I was somewhat suspicious of that, and you can see with the wind tunnel, the 2.0 unit, and I didn't put it in red because the Australian standard really is based on flux chamber measurements at 2.0 units, and the wind tunnel probably you can get away with a bit more, it's more like 7 or higher. But the 2.0 unit here sort of hugs the 1 kilometre and sort of sticks out in the northwest, which is inside the landfill area anyway, and there's a little industrial area there. And it comes in a bit here, but this is over near the Poultry Farm, so I'm not going to get many houses in there. But you can see that it may not warrant a change in the buffer. So what we did is the ambient odour surveys, and we were somewhat limited in this winter study to just using, just accessing this field here. This is an electricity substation where we couldn't get in there. And there's a golf course here, and there was some sort of construction going on here. So we did most of the surveys here. Some of the conditions we did them in the winter, we pretty much only got the odour to the back of this paddock. This is about 480, 500 metres to this corner, and most of the winds were coming from the northwest or west or north during this survey. So we were pretty much in the zone. This is the composite of 4 surveys in this image here. So we're looking at that. We thought, going back to the modelling, this is this field here. We're smelling it out here, and the model is saying in the 9th highest hour, 3-minute average, worst case conditions, which is going to be, before sunrise, the middle of the night, sunset sort of time. Not quite the times we were doing the ambient odour surveys. This is the maximum here. So we're all of a sudden, we're thinking, no, we're smelling it back here, so this is not right. Maybe this is more correct over here. So then in the summer, we did the same process, and we modelled it with the summer emissions, and we got the flux chamber all of a sudden is 3 or 4 times more emission in the summer from the sampling, and the wind tunnel was 5 times the emissions that we collected in the winter. And you can see the differences. Now the flux chamber is showing even it's pretty much out hugging the 1 kilometre buffer, and the wind tunnel now is much bigger. So we're thinking, what's happening here? And we did more ambient odour surveys in the summer, and we got this sort of picture. All of a sudden now we're getting odour over a kilometre away. We're getting a lot of odour in here, a little bit stronger. The white dots are no odour. You can see the heading here. The yellow is very weak. Green is weak. Distinct is blue. And we're getting to the north. We're getting odour at 1 kilometre away, and we're getting odour routinely here. And the thing about this survey here, in this one here, this is during 4 to 6 metre per second winds in mid-afternoon, so 2 or 4 o'clock in the afternoon. Bright sunshine, about 27, 28 degrees. So this is not worst case dispersion conditions that the model's going to pick out. So we know that if we can get it here in this probably quite good dispersion, 6 metre per second winds, then what's it going to be like under sort of more calm, stagnant, stable conditions? We did odour intensity concentration relationships, so that way we could look at the ambient odour survey data intensity and try and convert it to a concentration to try to understand the modelling. So this graph shows our attempt to validate the modelling. So it's basically the colour coding here is connected to the intensity values, and these are basically box and whisker plots showing the ambient odour survey ranges that we're picking up in the white, and the grey is the model. And the x-axis is the model cells that were where the ambient odour surveys were conducted. So this is the flux chamber up here, and you can see that it consistently underestimates, gets nowhere near the ambient odour survey results in the white, and the flux chamber does a little bit better. It still seems to underestimate, but at least it coincides on a few times. The means are always much lower. We filtered the model results for the types of conditions that we took the ambient odour surveys in, and we're attempting to validate the model. So it continues to show that if we go and use the Australian standard flux chamber method, we're going to be way underestimating the odour potential in this area from this plant. And then this just shows a plot of the actual turning event. So this is turning one stockpile. It's a lot more odour coming from the turning event. So then what we do is we combine that turning emission. And the turning is only done potentially between in operating hours, about 8 till 4 in the day. So we model 0 at night from turning. We just do it during the day, and you can see that it's basically the turning emissions for the flux chamber. The flux chamber is this tiny impact in here, and this is the winter one, and this is the winter here, and it sort of blends in with the other, just the stockpile emissions, whereas this one is just dominated by turning. And then you see in the summer, where we had much more odour from the stockpile, it blends in a bit more, and in the wind tunnel ends up being right out here, and it seems to match up much better with the possible. So obviously this is the 99.9th percentile. This is matching up much more with the ambient odour survey observations. So the second case study is the poultry farm. So this is the poultry farm area. Our subject site was in the red here, and essentially the whole site here was wanting to be developed, and the council, the client came to us originally and asked us to do odour dispersion modelling. They wanted this whole site here. I suggested we do ambient odour surveys because I don't know what the poultry farm does. I have no access to the poultry farm, I don't know any of the emissions. So how are we going to come up with an emissions profile and then model it in a conventional sense, like we did with the composting, where we had actual odour emission rates and we modelled out. In this reverse emitting situation, we have no emissions, and we've got to try and work out what the impact is at our site. So I suggested ambient odour surveys. They said no, we want to do dispersion modelling. So we used a reasonably well-known odour dispersion model, odour emissions model developed by another consulting company in Queensland on poultry farms, and we looked at the staggered bird cycles and what have you, and the numbers of birds, and regulation rates, and so on and so forth. And we modelled it. It was very conservative, and we got this massive 2.5. This is the compliance line, and it just touches the bottom of our site. So looking at that, don't have a lot of chance to develop on this site. However, the council has a generic 400-metre buffer from the nearest farm. So from this corner, there's a radial. You can see there's a sort of line, and this area here was later developed up to the line up to here. This is the line coming down here, and they basically said you can cut through here. If the line cuts through your site, you can build all this area. You can't build this area. So the client initially said, okay, we'll split this into 2 stages. We'll build here, and I'll see in a few years' time that we're going to come back and get this big. So this is the modelling I did when I was with another company about 8 or 9 years ago. About 3-4 years ago, they came. So that area, they ended up getting 31 lots, but they wanted another 15. It seemed to be for the developer that was where their profit lay. They'd sort of broken even on the first 31, and they were coming back for their profit. So as I said, it's a 400-metre buffer around the farm. So the issues we had were no access to the poultry farm, as I said before, and no understanding of bird growing cycles. Bird age in the cycle has a lot to do with odour emissions, so the diurnal and seasonal effects. Intensity and hedonic tone has a lot to do with poultry. It's usually a fairly unpleasant odour. And dispersion modelling was inconclusive initially. So we decided to do ambient odour surveys and to put a weather station on the site, on the development site. It was very important that we did that. So this was the way we did the ambient odour surveys. Essentially, we split the area into zones. It wasn't really possible to do full VDI or EN standard with grids. Even we're trying to use the plume chasing method in this, but you can see we're only allowed to get onto public access roads, so we can't really get back away from. It's very difficult to get downwind and off the roads. It's all private land. Our site is the blue site, and these dots basically represent all the sampling locations, the ambient odour survey locations we did. We started off the program with a 27 survey program over about 9 months. and then the council, we wrote a report, and the council's expert reviewed it and said you didn't do summer, and it was just the timing of when we were asked to build by the client, and you didn't do summer.